bitumen content, we are going to save foreign currency for our nation. That's the second point, very important. So we have saved environment and resources. So the cold and hot rejuvenation technology is there, which is already tested and performed well. We are working with NH1 for this technology. Now that would be a most interesting subject to you people. That is a replacement of reinforcement bar. It's a plastic armature. सभी लोग सरिया यूज करते हैं, मालूम है क्या होता है. That's a material which is 4 to 5 times higher in strength. That's a plastic armature. 4 to 5 times higher in tensile strength, and it is around 4 times lighter in weight. It doesn't rust. It is easy to handle. A 12 mm bar can be replaced by 8 mm bar. The dead load of the structure is lesser, so you need not to create a heavy structure. If anybody wants to feel it. It is the tensile strength of this armature is 1200 to 1800. Now let's get back to the soil stabilization, because I came here to address this subject only. This technology has been accredited by Indian Road Congress. It took me 2 years to establish myself in front of first IIT's batch people, committee member of IRC. So it has been tested very rigorously. This is an initiative from Transport Ministry of India, a circular being issued to all the departments. And here you can see at the 11th number ROADSTAB technology is here. This is a site, a website screenshot of Pradhan Mantri Gramin Sadak Yojana, as earlier Mr. Vikas has explained you, somewhere around 80,000 crore rupees are being issued to this organization to create our infrastructure. Here you can see in the technology sector, you see our ROADSTAB technology, and down there are around 450 km tenders which are to be constructed in Assam sector, and around 50 kilometers are there in Uttarakhand. Now you need to see what is a strength of a stabilized structure. Our E value, this is a recent, earlier it was some CBR value, etc. But now, here we have started come up with a IIEE, a program, a software which is being issued by the Transport Ministry of India. There you have to design any material. You have to take out the strength parameter of any material in E value. So when we talk about the E value of ROADSTAB structure, the structure which you are holding in the hand, it's around 5,000 to 8,200. For this structure, for 7 days UCS value for the mode you are holding is around 5.4. And that's for UP Express, Purvanchal Expressway. That's a mode from that. Now, we need to compare it with other materials which are conventionally available in road sector. Let's try to find out what are the E value of those structures. Structure of E value BC, bituminous concrete, and DBM, dense bituminous matter. The E value varies from 1700 to 3000. That's as per the coded provision of ISA 372012. E value 1700 is for BG30 and 3000 is for BG40. That's a viscosity grade bitumen. When I talk about the second layer, that's the WMM layer, wet mix minor. So it varies from 350 to 450. E value of WM layer. This is also considered as a base layer. Now, when we go for the next layer, that is a GSB layer, it is 160 MPa. Now, the downmost layer, considered as a subgrade, the recommended E value, the recommended CBR value is 8%. So if we consider as approximately 66.6 E value comes out, So it varies from 60 to 70, but in if I talk about Maharashtra, it's nothing more than 50, believe you me. It's nothing more than 50, because yesterday I had been to one project, all black of the soil. Now what are the solutions? Now, guys, you please concentrate over these slides, another 4 slides. These 4 slides are going to give you an idea how to look at the problem differently, not as conventionally as we people or our engineers are recommending us. We need to look at the problem differently and address that. The one is new alignment. That's a new alignment. New alignment, general structure you must have seen, BC, DBM, WM, GSP, etc. So if you are there, you need to propose a stabilized structure, because by doing this, you will be saving resources. You will be saving, financial resources of our country and environmental resources. Second one is widening. Widening, by doing widening, I will go in the next animated slide, you will understand what it is, but here I will just give you a brief idea. 3.75 one lane structure is to be widened to 7.5 meter structure. That is widening. All the structures throughout India are being widened. The third one is strengthening. Here you have an old structure which is in a very deteriorated form. So they need to remove the asphalt layer, upper layer, and they need to strengthen the base layer. After that, they need to put the asphalt back. By doing strengthening, we need to stabilize that strengthened layer. By doing this, we will decrease the asphalt layer, and that structure will be more durable. Asphalt rejuvenation, as I told you, the asphalt which will be thrown out, we need to mill that asphalt and we need to reuse that asphalt. We need not to take new material. We need to ask the contractor, we need to put in the DPR that please mill this material and rejuvenate it. Test it as per the required. We have all the resources to test the material. It has to be better than the virgin asphalt. And if it is, if we are able to, we need to take a chance to offer this layer, to propose this layer in the structure. And by the way, Mr. Vikas is doing his best efforts to do to help us to bring this innovations, this knowledge to Maharashtra. Now let's talk about the new alignment. TIP MSA. What is MSA? It's a million standard axle. You might not be knowing or might be knowing, but million standard axle is actually age of a structure. So when we talk about a million standard axle, this is a standard of 100 mm, 250 mm and 200 mm GSP, conventional. And when we compare it with the stabilized structure, there you see that 1200 mm road stab layer. Overall thickness goes down from 550 to 340 mm. These structures are being tested under IIEE. Now, in this 200 mm, you have got this material from mountains. You have crushed those mountains, those rocks. Here you have used in situ material, the soil which is lying there. Here you have 250 mm structure. Again the same rocks. Here you have used 100 mm crack relief layer. This can be replaced by SAMI layer. There is another option, a cold formation requirement. There is that can be considered as a SAMI layer. There you need not to put 100 mm again rock. You can remove that, eliminate that as well. By having a very strengthened, high strength base layer, you are able to decrease the crust thickness of asphalt layer as well, which is again very expensive. 100 mm asphalt goes down to 40 mm asphalt. There we have saved 60% of asphalt material. We have saved around 40% in the rock material. This is a new alignment structure. This is a structure which we have made for in 2013 in Patna Bakhtiarpur. Now, one thing just I am saying, the second thing I am proving. These are the data, these are the statistics from the IIED. IIED is a software from the government for designing. Now here you see there are two tables, there are two columns. In one column you see allowable strain. The other one is actual strain, observed. Here you see allowable strain is calculated. Here you see actual strain obtained from IIED. We have just used 20%. 20% of the value achieved in the laboratory. Suppose, as I said, around 5 MPa I have achieved in my laboratory. But while designing, I will be using only 20% of the value. Only 20%. And by using 20% of the value, this is the strain which comes, and this is the strain which is permissible for this 10 MSA structure. 10 MSA structure. Here you can see 356.1 is permissible, is allowable. Whereas we are using only 20% of the E value, and actual which is coming is 100.2. I mean, government permits at 356 and we are giving only 100.2. Simultaneously, vertical compressive strain over the substrate, which is 673 is permissible. We cannot exceed that, but 673 is the limit. By using about only 20% of the value, it comes 490. This is showing that structure is safe. This you have seen here. Now I will prove this thing in physical mode. Before that, let me give this 3.75, how we do that. Conventional widening. Generally, there are a lot of roads. Even in, yesterday, I have at least one structure. What was the company's name? Some Pune, Pune's road is there. Sri Associates. So they are widening 4-lane here. They are widening 2-lane structure to 4-lane. What are they doing, and what is the proposed structure from the government? Here you see, there's the asphalt layer, WM layer, GSB layer. How do they widen this road? They remove the asphalt layer, they strand the WM layer. Then what happens is, they take new material, they do GSB layer, put WM layer, above that they put asphalt. This is what they do. I said you think beyond the limits. That is engineering by. Now, there is a problem by doing this. After a few years, because the structures are different, the quality is different, what happens is there's a crack arises in between those two old structure and new structure. And what ROADSTAB proposes? This is the ROADSTAB solution for widening the road. What you see is, we remove the asphalt layer of 100 mm. We take 100 mm of old WMM. We mill it. Then the rest material is 350 mm. We excavate this material in an area, dump area. After doing this 350 mm structure can be extended to 7-meter structure without adding any new material. Will add either soil. 200 mm 7-meter ROADSTAB layer being constructed by using all old material. Then this old milled WMM and milled asphalt, it works as a crack and leaf layer for 100 mm for 7 meter without using any new material. The only new material which is being used, that is the asphalt layer, and that's again 60% lesser which was required. So here you see, we have reused all the material, we have saved environment, we have constructed a structure which is 4 times durable than the conventional. 4 times durable. There's a test named as durability test, which is wet and dry cycle. You need to keep 12 hours mold in the water, then you need to dry it in 12 hours in the oven, then you need to brush it with the steel brush. And by doing 12 cycles, you will be able to get the performance results of 12-year age of structure. Permissible is 20%. With stabilized structure, with road stabilized structure, it comes nothing more than 4 to 6%. We have whatsoever I'm saying, are being confirmed with certificates. Any of you would be able to contact me anytime and would be for any query or for any certification you may ask me, and that will be provided to you. Now this is a standing solution. The same, we do not touch GSB here. We strengthen the this 250 mm WM structure with ROADSTAB and adding some soil. Above that, we use 100 mm leftover material that made asphalt material because it's again to be thrown out. We are using it as a crack relief here. And above that, we will use only 40 mm new material, and the structure will be more durable in comparison to any conventional methodology. For your example, I will just use, I'll be showing you the data. For your example, 5 MS structure, if we do it with a ROADSTAB, we'll get the 50 MS structure. I'll show you the certificate again. This is the asphalt rejuvenation, how we do it. We remove the structure for 40 mm. We strand the DBM. We strand the WM layer. We rejuvenate this material, milled material, by doing hot processing, by doing conventional machinery without new machinery. That's one of the very big concerns, by the way, in the industry, that you need to work with a conventional methodology. Of course, you can bring in new machinery, innovative machinery, but that's not in the capacity of every contractor because, by the way, one point is missed here in Mr. Vikrant's presentation. Government is trying to bring up small contractors as well. They have divided those sections in small sections so that every small contractor can also participate. That's one of the new opportunities, by the way.